Hey guys, this will be your last pre-algebra video for this year for your FSA review. So let's just go ahead and get started. We're going to be talking about rational versus irrational numbers. And let's just go ahead and take a look here. Please remember that you do have that last standards checkpoint in USA Test Prep. It is a grade, so please make sure you've gotten that done. And let's just take a look. So select all the numbers that are rational. So in order for a number to be rational, it needs to be a non-zero whole number. Okay, so non-zero whole number that could be written as a proportion where the decimal, if it is in decimal form, either repeats, this does not want to work, either repeats or terminates. So let's go ahead and take a look at these. The square root of 9. Well, the square root of 9 is 3, and 3 is a whole number, so that's rational. 4.6 is a decimal that terminates, so that's rational. Negative 4 2/3. 2/3 repeats itself, so that's rational. Negative 12 is a whole number, so that's rational. The square root of 2, if you were to plug the square root of 2 in, you would get a non-repeating, non-terminating decimal. So that is not rational. 3.14 terminates, so that's rational. Negative half is equivalent to negative 0.5, so that's rational. Pi is irrational. 22/7 is irrational. If you look, this decimal does not repeat. It does not terminate, so that's not rational. This decimal up here repeats, so there you go. Rational versus irrational. All right. So remember, anything that's rational can repeat or terminate. It could also be a whole number. All right, so that's what you're looking for in determining rational versus irrational. Okay, so this problem says which decimal is the equivalent of 6/11. So when we're trying to find what is the decimal equivalent, we are taking the denominator, putting it outside, putting our numerator inside. So 11 does not go into 6. But if I add a decimal point, I can make this 60. So 11 goes into 60 5 times. 11 times 5 is 55. So when I subtract, I get 5. Well, again, 11 is not going to go into 5. So if I add a 0, 11 does go into 54 times. That would be 44. So 50 minus 44 is 6. And look what's going to start happening. 11 does not go into 6, but it does go into 65 times. And we're going to be continuing this pattern. 11 does not go into 5, but it does go into 54 times. So if you look, this 54 is going to start repeating itself. So because the 54 is repeating itself, D would be our answer. All right, this is definitely something that you may see on the FSA. It says graph the square root of 6 on the number line below and explain how you determine its location. So in order to graph the square root of 6 on the number line without a calculator, we need to think about the square roots that surround 6. So perfect square roots would be the square root of 1, the square root of 4, the square root of 9. And so the square root of 6 actually would fall right between those. So when we go to approximate this, we know that the square root of 6 has to be between 2 and 3. So probably somewhere right along here. And the reason we know that is because 6 is between 4 and 9. And so the square root of 4 is 2 and the square root of 9 is 3. The square root of 6 has to be approximately somewhere in between those. All right, last problem. I want you to approximate the value of the square root of 20. So what is the square root of 20? So again, you got to think to those square roots that you know. So it goes square root of 9. Then we've got square root of 16. Then square root of 25. So if we were to line these up on a number line, we'd have the square root of 9, which is 3, the square root of 16, which is 4, and the square root of 25, which is 5. So the square root of 20 has to fall somewhere in between 4 and 5. So your best guess would be 4.5. All right, guys, that is it for the videos for this year for your FSA review. Please make sure you ask any questions on any standard, and I look forward to seeing you all soon. Adios.